Welcome everyone. Today we are going to cover the topic of projectile motion. So when body is in motion, that part will be covered in dynamics. Okay, and in projectile motion, definitely body is in motion. So first of all, we will deal with the definition of projectile motion. If a particle is freely thrown in the air along any direction other than the vertical, it will follow a curved path which is parabolic in nature, and this motion is called as projectile motion, and the path traced by the projectile is called as the trajectory. We have to neglect the effect of air resistance. Okay, so this is the projectile motion. Okay, what is projectile motion? If a particle is freely thrown in the air along any direction other than vertical, it means that we don't have to throw that particular body in vertical direction. Okay, if the body is thrown anywhere in the air along any direction other than vertical, then it will follow a curved path which is parabolic in nature, and this motion is called as the projectile motion. And the path traced by the projectile, that is the thrown body, projectile means the thrown body, and the path traced by the projectile is called as the trajectory. So in the analysis of projectile motion, we neglect the air resistance because which is negligible. Okay, projectile motion is the combination of horizontal and vertical motion happening simultaneously. Okay, have you if you observe carefully, the sixer hit by the batsman in cricket match. Okay, the body is, if the sixer hit by a batsman uh, in the air. Okay, so if you observe carefully, that ball traveling along traveling in the air, covering the horizontal as well as vertical distance simultaneously. It means that the projectile motion is the combination of horizontal and vertical motion, and both motions happening simultaneously. The particle is projected. We can say that the only force acting on the particle is the gravitational force, which is acting vertically downward. So in case of projected particle, the, the only single force is acting, which is nothing but the gravitational force. The gravitational force produces change in the vertical component of the velocity of the velocities of the particle. As is previously we have said that the projectile motion is the combination of horizontal and vertical motion which happens simultaneously. Okay, so the gravitational force produces change in the vertical component of velocity, because in projectile motion the velocity having two components, one along horizontal direction and one along vertical direction. That's why particle gaining vertical height simultaneously it covers horizontal distance. So all of you getting? So in projectile motion, particle is gaining height and simultaneously it covers horizontal distance. Okay, and this vertical component of force is influenced by the gravitational force. Okay, however, the horizontal component of the velocity remains constant. Thus, we may conclude that for a projectile, the acceleration along horizontal direction is zero because the velocity is constant. It means that when velocity is constant, that is acceleration is zero, because when velocity is constant, it means that a body is traveling with velocity of 40 kilometer per hour. Okay, throughout its traveling period, it means that we need not to accelerate that body. Okay, so when velocity is constant, acceleration is zero, and here acceleration along horizontal direction is zero because velocity remains constant along horizontal direction, but body is influenced by the sorry the vertical component of forces changes continuously because of the gravitational force of attraction. Hence, Acceleration along vertical direction is 9.81 meter per second square. Okay, here I have shown it in downward direction. Thus, the projectile motion is the combination of horizontal motion with constant velocity and vertical motion under gravity. And this is the uh, uh, and the general. Now next part is the general equation of motion, will and that part will be covered in next video lecture. Thank you so much.